Have you ever looked up after a rainstorm and wondered how a giant arc of colors suddenly appears in the sky? Why does a rainbow always show the same colors? Why is it shaped like a curve? And if rainbows aren't physical objects, where exactly are they? Today, we're going on a fascinating journey inside a tiny raindrop to uncover the science behind one of nature's most beautiful spectacles. By the end of this video, you'll understand exactly how rainbows form and why every rainbow you see is uniquely yours. A rainbow is not an object that exists in one specific location. You can't walk up to a rainbow and touch it. Instead, a rainbow is an optical phenomenon, a beautiful trick of light created when sunlight interacts with countless water droplets suspended in the air. Three ingredients are needed: sunlight, water droplets, and an observer. When these three ingredients align perfectly, the sky transforms into a giant natural prism, producing the colorful arc we call a rainbow. But to understand why this happens, we first need to understand sunlight itself. At first glance, sunlight looks white, but white light is actually a combination of many different colors. The colors are red, orange, yellow, green, blue, indigo, and violet. Every color has a different wavelength. Red light has the longest wavelength. Violet light has the shortest. Although all these colors travel together through space as white light, they can separate when passing through certain materials like glass or water droplets. This separation of colors is called dispersion, and dispersion is the first key step in creating a rainbow. Imagine a single ray of sunlight traveling toward a tiny raindrop. When light moves from air into water, something interesting happens. It changes speed. Light travels slightly slower in water than in air. Because of this change in speed, the light bends. Scientists call this bending refraction. But here's the important part. Each color bends by a different amount. Red bends a little. Violet bends more. As soon as sunlight enters the raindrop, the colors begin spreading apart. This is dispersion in action. The story doesn't end with refraction. Inside the droplet, the separated colors continue traveling until they reach the back surface. At this point, most of the light reflects off the inside of the droplet. Think of it like a tiny mirror hidden inside every raindrop. The light bounces off the back wall and starts heading toward the front again. Now the colors are traveling in slightly different directions. This reflection is the second crucial step in rainbow formation. As the light leaves the droplet, it passes from water back into air. Once again, refraction occurs. The colors bend even more. Now they emerge from the droplet as separate colored rays. Red light typically leaves at an angle of about 42 degrees. Violet light leaves at around 40 degrees. This tiny difference creates the colorful separation we see in the sky. One raindrop alone produces only a tiny amount of colored light. The rainbow appears because millions of droplets are performing the same process simultaneously. Each droplet sends a specific color toward your eyes. Some droplets send red light, others send orange, others send yellow, green, blue, and violet. Together, they create a complete spectrum stretching across the sky. The rainbow is actually assembled from light arriving from countless different droplets. One of the most common questions is, why are rainbows curved? The answer lies in geometry. The droplets that send rainbow light to your eyes all lie on an imaginary cone. The angle between the incoming sunlight and the outgoing rainbow light is approximately 42 degrees. Because millions of droplets occupy this cone-shaped region, the rainbow appears as a circular arc. From the ground, the Earth blocks the lower portion of the circle. That's why we usually see only a semicircle. Pilots sometimes see full circular rainbows from above the clouds. The rainbow was always a circle. We usually see only part of it. Here's something surprising. No two people see exactly the same rainbow, even if they're standing side by side. Why? Because each observer receives colored light from a different set of raindrops. Move a few steps, and the droplets sending light to your eyes change. The rainbow moves with you. In a sense, every rainbow is uniquely yours. Sometimes a second rainbow appears outside the first. This is called a double rainbow. Instead of reflecting once inside the droplet, the light reflects twice. This changes the exit angle. The second rainbow appears larger and fainter. Even more interesting, the color order reverses. That's why the outer rainbow looks different from the inner one. Rainbows come in many forms. Fogbows are created by tiny fog droplets. Moonbows appear at night, when moonlight replaces sunlight. Waterfall rainbows form in the mist of rushing water. And circular rainbows can be seen from aircraft high above the Earth. Each follows the same fundamental principles of refraction, reflection, and dispersion. So the next time you see a rainbow, remember what's really happening. Sunlight enters millions of raindrops. The light bends. The colors separate. The rays reflect inside each droplet. They bend once more as they leave. And together, those countless droplets paint a magnificent spectrum across the sky. What looks like magic is actually a breathtaking demonstration of physics, geometry, and light working together. Nature's beauty often hides incredible science, and the rainbow is one of the most spectacular examples.